folks, Heidi here from SAIC. I'd like to talk to you a little bit today about why we want to use design structure matrices on more of our programs. And one of our key drivers is a requirement in the defense industry called MOSA, the Modular Open Systems Architecture requirement. This requires that systems not be designed as one giant block, but they have components that are not highly coupled, but they're highly cohesive. They have well-documented interfaces so that the customer can procure those components independently and avoid vendor lock. And MOSA has become increasingly important recently because there's a desire to transition quite a lot of software in the industry to more modular microservices and to focus on the sustainability of systems over time, because that's where a lot of money gets wasted. There's also a desire to focus on the idea of architecture, something that isn't just happens once at the beginning of a program and then you abandon the architecture, but something that is maintained and enforced through time, so that if I have an architecture that meets the requirements of MOSA, I actually implement that architecture, and that is what is delivered to me. And that we want to be able to look at architectures in a more sophisticated way than we typically have. A lot of the MOSA principles are often evaluated qualitatively using sort of expert opinion, and we wanted to look at things from a more rigorous perspective. So the technique that we decided to adopt when trying to kind of soup up the way that we are approaching MOSA is design structure matrices. And in particular, we were looking at a combination of tools to help us enable that analysis called Lattix and Cameo System Modeler. And our primary use cases that we wanted to achieve is to be able to evaluate architectures that are proposed, evaluate the code as it's developed, and to compare that delivered code to a promised architecture. So one of our focuses is to try to really look at architectures in a more rigorous way, where I can actually have metrics about how coupled my architecture is, and that I can track those metrics over time to make sure that my architecture doesn't degrade. But in particular, one of the real changes that we wanted to make is that MOSA is often evaluated late in the development cycle, when nobody really has any interest in saying this architecture isn't modular. At that point, things are already being built, and a lot of money has been spent based on whatever architecture was proposed, and there's a tendency to kind of rubber stamp architectures for MOSA compliance rather than really looking at them critically. And in our opinion, the only way to change that is to do it earlier, when it's possible to really make meaningful changes to that architecture. So there's a trend in industry right now to build system models, typically in SysML, and using tools like Cameo to document what the architecture is. And what we were wondering is there a way to take that model and do the DSM analysis in a way that's more automatic than the processes that we were using in the past, so that we could do it quickly and we could do it repeatedly, and we could track those metrics over time. And so we went out and we looked, and there are existing tools out there like Lattix that do this on software code, and we were wondering, well, our model is code. Could we import that, and could we analyze the architecture before code even exists? And Lattix, in fact, is working on that currently, and we've been kind of partnering with them on this because while Lattix can ingest the model very easily, it's not as savvy on like what in the modeling language is what is a meaningful dependency. And so we've been trying to focus on getting an output out of Lattix so that we can get readable and informative results that make sense to systems engineers, who are the ones who are going to be evaluating that architecture. And then once we have a good architecture, it's our intention then to track the build of software against that architecture over time. Lattix already has capabilities where you can define architecture rules in it, we would like to get the architecture rules directly from the model and then compare it against the code and make sure that the architecture that we are promised is the architecture that gets built in the code. And our hope is basically to make MOSA, a lifetime a lifetime process that you have to evaluate as long as the system is in the field and is being upgraded, so that compliance to MOSA becomes something that is not a one and done. It is not a rubber stamp, but it is something meaningful that really improves the capabilities and the sustainability of our systems for our warfighters. Thank you.